and welcome to Chapter 12. In Chapter 12, we're finally going to introduce exception handling. I know, I could have done this about 10 chapters ago, and it might have been useful, but we wanted to make sure that you understood all the basic concepts before we got here. So now we're going to finally handle all of that validation testing, all of the things that we've been doing to make sure that users enter the right information and that you create your functions correctly. Let's get started. The first thing that we're going to talk about is what is an exception? So an exception is defined as an unexpected or an error condition. So this is where you try to read from a file, but the file doesn't exist. You try to write to a file, but the disk is full. You ask for user input, and they give you the wrong information. The dreaded divide by zero, or I'm sure all of you have seen at some point, the index out of bounds error. These are error conditions or unexpected conditions. You don't expect your users to do this. However, because we realize in reality people don't always do what they're told, sometimes this is going to happen. The most common one I'm sure you've run into is if you ask the user for an integer and they gave you a string, or if you ask them for a string and they gave you an integer, something along those lines. So you end up with an error. These are all called runtime errors. These are not your syntax errors with the squiggly red line underneath them. None of these will happen before you compile. They'll all happen after you've compiled, everything looked like it was running fine, and then the user started using your system and something broke. So something happened in the middle of your code that you didn't expect to happen. These are called exceptions, and we need to handle them if we can. There's two different types of exceptions we talk about. Either an error, where something actually broke in the code, you couldn't have prepared for it, and you can't recover because without the piece of information you were looking for, or without the loop doing what it's supposed to do, you can't actually complete whatever the assignment was. You can't finish the program. The other type is called an exception. With these, it is possible to recover. These are validation errors. Please enter an integer. No, I'm not kidding. Please enter an integer. I really, really would like it if you'd enter an integer. Oh, wait, now you entered it. I can keep moving. So we can handle our exceptions if the user has entered something wrong, if it's a validation error, or if there's something in the input that is not the way we wanted to. We can gracefully handle it and not have the computer crash. We don't want the code to crash. We don't want to get an exception that causes it to crash. Over on the left-hand side of your screen is the stack trace. And I'm sure you've seen this at some point while you're doing your code, where you type in a number and you get an input mismatch or something along those lines, and it runs what we call the stack trace. In a computer, when a program is running, there is a stack that is filled the whole time with different methods. So I'm in main. From inside of main, I'm calling another method. So I'm going to go into that method. And then inside that method, I'm going to go create an array. So I need to go into the array methods. And inside my create array, I'm now in my constructor for my array. There may be another couple of methods inside there. Your stack trace is listed from the bottom to the top in terms of where you entered the code. So the very top of your stack trace, when you get your exception or you get your error, is going to be where did it actually crash? This will usually be inside of one of the utility methods. In the examples here, it's inside of the Java utility mismatch exception, the utility scanner throw for a scanner. In this case, it's a error that you can't do anything about. It's inside the Java utility, and it's there for a reason. It's because you were trying to turn a string into an integer, and it didn't know what to do with it. So it threw an exception at you. The top one usually isn't one that's going to do you much good. You can't change the scanner code. There's nothing in there, and you shouldn't want to. It should be fine. So when you're looking at your stack trace, you want to scroll down until you see something that looks like your code. In this case, we can scroll down that first exception and we'll see a division.main. So inside of our main, inside of our division class, on line 11, where it says division.java:11, that's what line it's on, is where this exception occurred. So you can be able to read your stack trace from your exception to find out exactly where the problem was. I actually use this a lot in the real world, where a client will call me and say, there's a problem with the code, something broke. Okay, it doesn't happen often, but every once in a while it does. And I can say, can you screenshot me the stack trace that just printed on your screen? And they can screenshot me exactly what I'm looking at, and it'll tell me right away exactly which line of my code to go look at. This is awesome. So that's your stack trace. The list that's on the bottom on the left is a list of types of exceptions. We have exceptions that are throwable. Throwable meaning that they can be thrown back to you and you can handle them. So we can throw these exceptions at you and say, here's an exception. What would you like us to do about it? Inside of exception, we have IO exceptions, which is input output. We also have language errors. We also have virtual machine errors. There's a ton of them. Runtime errors, arithmetic, index out of bounds, no such element. All of these are errors and exceptions that you can find. And this is straight out of the Java docs list of throwable exceptions. So you can see the different types of exceptions that are allowed. There's two different concepts that we talk about when we talk about exception handling. The first is robustness. Robustness refers to how robust, how well your code handles errors. If your code doesn't handle errors at all, if you have no error handling going on at all, your code isn't very robust. So it's not doing very good of catching those errors. So robustness is kind of a degree of how well are you handling errors. Most of the code up till now probably is not very robust because you're probably not handling any errors. We haven't done exception handling yet. The other is what we call fault tolerant. How prepared are you for cases that will make you fail? So these are things where you're going to look at your code and you're going to say, at this point, the user might enter this type of problem. So how can I handle it? So preparing your code to fail is your fault tolerance. Okay, so those are a couple things about exceptions that you're going to need to know. Let's move on. Okay, one of my favorite ways of describing error handling or exception handling is trying and catching. When we write our code, we can put our code inside of what is called a try-catch block. Both the try and the catch are their own individual blocks. So I guess try-catch blocks. Your try block will tell the compiler when you are running this code, it might fail. If it does, please just send me over to the catch statement instead of just blowing up, because I don't want you to blow up. It's annoying. So the try part of it will tell you to do that. The catch section is where you handle the exception. So an exception comes in, an index out of bounds. What do you want to do if an index out of bounds happens? This would be the case where if you have a 15-character array or an array of 15 sized array, and you have a bunch of strings and the user tries to enter the 16th string. You can catch that and say, hey, you tried to enter the 16th string. We can't enter anymore. And go ahead and fail nicely and just cancel out of our loop or whatever it is we need to do at this point. That way the code doesn't stop. You don't end up breaking the code if the user tries to do that. You just keep going on nicely. You might prompt them and say, hey, probably shouldn't have done that, but you can handle it nicely. So the catch block tells the compiler, if I do end up failing inside of my try, I'll handle it. I'll take care of it. Let me do that. Go throw me the exception. Give me the exception and I will handle it. Okay. The exception that you get, so there is a variable inside of a catch that is a type of exception. Exception is a type. Now that you know about inheritance, you can do understanding the concept of subtypes or subclasses underneath exception. But exception is the parent type of all the exceptions. All the exceptions you're going to get are some type of an exception. When you get that, it usually has a get message method that might tell you something else about it. You can print that message so that when you're looking at your code while you're testing, if you fall into that try catch and you fall into the catch, you can have that message print out to your console and tell you exactly where you screwed up, exactly where the error is in your code. Gives you just a lot more information while testing. It also gives you a lot more information when your user is actually using it. So you might be able to say, hey, you tried to enter the 16th value at this point because I have the message that tells me that's what you tried to do. Or you tried to enter a string into an integer. You tried to pass 3 as a word instead of 3 as a number. Go back and give me the integer. Okay, so this is how you can use a try-catch block to handle exceptions. Let's move on. When you have a try-catch block, it's really important for you to understand those are blocks. Remember, scope, back to our scope. Try and catch blocks are only visible within that block. The data from a try is not available inside of your catch. They're separate blocks completely. So before you start your try, you might want to instantiate a variable or something like that so that you can access that from your catch, if that's something you need to do. We can go back to the idea of only instantiate it outside of the block if you need it outside of the block. If you don't need it outside of the block, put it inside the block. It's more clear. So if you want to declare the variable outside the block, set it within the block and call it at the end underneath it all, but you never instantiated it or initialized it, that might be a problem. So make sure that on your int x here that you at least set it to 0 or something to begin with, because it still may not be initialized. If you declare it within the block and then use it, and then try to use it outside the block, you may get it's out of scope. So if I did an int x inside of my try block and then I tried to reference it outside of my try block, it's out of scope. It doesn't exist anymore. So remember where your scope is inside of your try-catch blocks. The try is a block of its own, and a catch is a block of its own. One of the convenient things that we can do is we can throw and catch multiple exceptions, different types of exceptions. You can kind of think of this as overloading your exceptions. If we have an arithmetic exception, go here. If we have an input mismatch, go here. And you can give it different types of error messages that you're going to print out to the user or print out to the console based on which exception was given. So because you can have multiple statements inside of your try block, remember the first exception will be the one caught first, and then it'll jump down to the catch. It will not jump back up to the try after you've handled it. It goes to the bottom. So if I am doing this try-catch block and I have an error at numerator, I am never filling out denominator or result. I'm stopping at numerator and I am jumping straight down to the catch on input mismatch, because if you put in a string instead of an integer. If I do it at denominator, that's fine. It'll go handle it in input mismatch, but the result will never get set. And if I do it at result, it'll jump to arithmetic exception if my denominator was 0. And say that there was a problem with my math at this point. So you can catch 2 different exception types in the same block. However, remember only the first one gets caught. So as you're going down, if you didn't get the right answer, you're going to have to handle it nicely and either go back up to the top of your loop or find some way to handle that. Preparing for the unexpected exception. Sometimes we like to throw at the bottom a catch block that's just exception. It's not an arithmetic exception. It's not an input mismatch exception. It's not an index out of bounds. It is just an exception. So that if we got an exception that is so not what we expected input array, input mismatches or out of bounds or something like that, and we got some really funky exception, the power ran out, something like that. The file we were reading got used by another person and we weren't planning on file IO errors. In that case, you can have a catch just as a base exception. Your exception is not abstract. It's a class by itself. You can use it. A lot of times we like the defined exceptions like the arithmetic or the input mismatch because they only grab those exceptions. And so we can make the comments underneath the catch block be specific to the error that was made. So rather than just doing catch all my exceptions, I can catch certain exceptions and handle them nicely. Throw my catch exception mistake at the very bottom and just say, you screwed up, I'm not sure, it was something I wasn't prepared for. Okay, so multiple exceptions can be handled. On top of your try-catch block, we also have the option of a finally. Finally is really useful when you are using things like file IO or a scanner. We haven't really gone into file IO yet. You'll do that in the next chapter. But in this one, finally, it gives you the option of doing something even if you ran into the catch. So resetting variables, closing your scanner, closing your file IO, handle the crash in your catch, but then in the finally. And what'll happen in your code is if everything works lovely, you'll go into your try, you'll run all the code in your try, you won't have any exceptions, and then you'll run the code at your finally. If something did go wrong, you'll do some code in your try, then you'll jump into your catch, handle it, and you'll still run the finally no matter what. So the finally code allows you to run code no matter whether an exception was caught or not. These are usually used for cleanup. So things that you don't want to break the system or move on without running this cleanup code. And we couldn't run it because we weren't able to run through enough inside of our try catch to get to the cleanup code. So instead of putting it there, we throw it down at the bottom and we put it in a finally. They are in order, try, catch, finally. Don't try to put your finally before your catch. It'll get very confused. So try, catch, finally allows you to do your cleanup. I do recommend closing your scanner. I know a lot of you have not been doing that, so please start closing your scanner. It's better with the scanner. All right. Why do we do exception handling? Why? What's the advantage of it? So I want you to think about how much of your code is spent filling out if the user entered the wrong information, then do this. Otherwise, go do this. So you got a bunch of nested if statements somewhere in the middle of your code, just checking, did the user do everything that they were supposed to do? In this case, with try-catch blocking, with exception handling, I can run my code assuming everything is perfect. So my code is actually very clean because all I'm saying is do this. This is exactly what you should do, assuming that they put in the right information. This is what you should do in this case. This is how you should handle this, and get to the end. Now, if there are errors, they'll fall down into your catches and you can handle them there. So the other thing with exception handling is you can handle the multiple types of errors in different ways. I can have a piece of code that says, please enter an integer next time. Oh, wait, you did this wrong. You can have some code that says, oops, we ran out of the deck and the deck is empty. We need to handle that. It also allows you as the programmer to figure out how to handle each specific error. So it doesn't have the compiler handle it. It doesn't have the runtime handle it. You get to handle it. How do you want to handle the error? Can you run a loop and go back up to the top? Can you set it to a default value and move on? You get to decide, and it's up to you as the programmer. So it's really convenient to do that in exception handling, cleaner code, handle multiple errors, and lets you handle how to do them. In this case, we're going to talk about optional exceptions. This is where you write a piece of code and you know ahead of time that that piece of code might throw an error. So you already know when you do a system out and you reference an index from an array that you might hit an index out of bounds because the user might enter an integer that was too high and it might be out of bounds. So you know that's a possibility. With optional exceptions, you can declare a throws clause. So you can say that my method displays price throws an index out of bound exception, which will let the rest of my code know, hey, that's the exception that this one throws, which is great. It allows you to prepare for your exceptions in your main code because your class code already tells you what errors it throws. So in this case, if I have my main code here where I'm doing display price and I'm passing an integer that the user entered, I'm already prepared to handle the index out of bounds because I was told that price list display price will throw this error. The code will usually pop that in there for you, but it might also yell at you if you don't handle it. So it prepares you ahead of time for these are exceptions that might pop up, and I can handle them without having to remember, oh gosh, what are all the exceptions I have to remember? Well, which ones are thrown from your methods? So exceptions can be either unchecked, where you don't handle them, or checked, errors that you reasonably prepare for and recover from. Sometimes it's okay to not check the error or the runtime exception. Sometimes that's okay. If you don't catch the error in the method itself, you should probably specify it in the declaration that you're not handling the error. One of the things that can happen is sometimes you have code that you can't reasonably recover from and you need to let the error go through. It's going to blow up your system, and you know that because here's an error you weren't prepared for and you need something to happen to tell you that there was an error. Some programmers will run through and they'll put everything in a try catch block and they will catch every exception even if they don't handle it, and then they'll run their code and go, cool, nothing broke. Well, sure, nothing broke, but it also didn't work right, because if I entered a string for an integer and you handled it by setting it to 0, well, that's not really how it should be handled. Let's go figure that out. So in some cases, you want unchecked errors. You want to have exceptions that are allowed to go through because you want to know which exceptions are they so that you can handle them nicely. Or you want them to go through and say, this is going to break the code. Since you didn't enter the right information, we have to stop here. Okay? Syntactic sugar and syntactic salt. So these are coined terms that programmers came up with of, remember, our syntax and our semantics. Syntax being our rules and our code, whereas our semantics is our logic. So syntax or syntactic salt is something that makes it better. Syntactic sugar makes it easier to write. So syntactic salt are things like error checking, that it makes it harder to make bad code because I'm preparing ahead of time. I'm thinking through my algorithm. I'm looking for my test cases, looking for cases where the user could screw up, and I'm getting them all handled ahead of time, which means it's harder to make bad code that breaks if you have a lot of syntactic salt. Java likes to make things pretty and easy, so try-catch blocks were a part of what we called syntactic sugar. They're kind of like syntactic salt, but they make it so much easier for your programmer. So they're easier to write. Just a little couple of words that we like to use in the language. Okay, so I've already introduced you to the call stack, but I do want to bring back one more time. You've noticed your call stack. I know you have, because it's there. Whether you've read it or not is different. You may have looked at it and went, I don't know what any of that means. I'm just going to quit. Your stack trace will pop up if there are examples of unhandled exceptions. If you have not handled your exception, your stack trace will pop up and you'll crash the code. So you'll get an exception. It also tells you exactly where in the code you should be able to find your error, describing the method and the number line as they occurred. So again, the bottom of the code is usually your main, whereas the top is usually the method in your utility, might be inside of your code itself, that broke, and it threw an exception at that point. So you can use your error.print stack trace if you want to call the stack trace from inside your catch block. If you catch and handle your stack trace or your exception, you may not see the stack trace and you may not know where that happened. But you might want to use your print stack trace method to be able to see from your point of view during testing to find the error number and line of where the error occurred. So you can always use your error.print stack trace. The error in this case, by the way, is the variable that was handled in your catch. So as you see, your catch takes an exception type, one of the either exception or one of the subclasses of exception, and a variable name, which we're using as error. You don't have to, you can call it E for all I care. And then it would be E.print stack trace. So whatever exception is being handled, that's what comes in, and then you can call print stack trace on that. All right. So now we're going to talk about how you can make your own exceptions. So of course we want to handle all of the obvious ones, dividing by 0, index out of bounds, exception. But sometimes you want to have an exception that is just specific for your class. Like when you have your deck and you're trying to call a card out of your deck that you want to deal 3 cards, but there's only 2. So I want to make an exception that says the deck isn't large enough for you to get the cards that you want, or the deck is empty, or something along those lines. So if I wanted, in my case, I'm sure when you guys wrote your code, you did a lot of checking. Is the deck empty? If it is, then go do this. Otherwise, go do this. You can actually just throw that in a try catch block and then catch the is deck empty exception that you can build on your own. It's very important. It's going to extend either throwable class, either exception or error. You can use the constructors that are there. Exception doesn't take anything, or it can take a string message, or it can take a throwable cause. We can talk about those a little further along. So it can take one of those. In this case, we have just used the constructor with a string. That's our message, saying customer balance is too high. You could say super and your deck is empty. And then you can use those custom exceptions to create your exception messages inside your code. So as you can see, this one, they said, if the balance is a high credit limit, I can throw a high balance exception. In your deck, you can say, if the deck is empty, throw deck is empty exception. And then you handle it nicely. It's a handled exception, nothing broke, and it was cleaner and obvious to anybody who's looking at it that you have this exception, you prepared for it, and you moved on. So creating your own exception class. One of the things that we do in error or in unit testing is we make assertations. We assert things. Asserts are things that say, I expect this to be something. And if it's not, I want you to do something about it. I'm going to detect my logic errors. You can throw asserts all over your code. I actually think they're great because you're going through your code and you're making assumptions all over the place. I'm assuming that my deck is full. I'm assuming there's cards left. I'm assuming that I haven't hit my max yet. I am assuming this, that, and the other. But you can throw stuff in there with an assert to just verify, hey, I want to assert, is my deck full? Is my deck empty? Can I check that before I do something? So in this case, we've done an assertion on, is it even? And we have said if the number is mod 2 is equal to 1, then the result is false. It's not even, it's odd. Otherwise, the result is true. Okay. And we're going to assume that if the number mod 2 is equal to 0, because we knew it wasn't equal to 1, so we assume that it's going to be either 0 or 1. Funny thing is, if you put in a negative number for your number, your mod is actually -1. So if I put in -5, that will come back as yes, it is even, because of the way this code is written. By throwing in the assert right there, saying that the number mod 2 is equal to 0, I can print an error message saying the number mod 2 is actually -1, which shouldn't have happened because I didn't write my code right. In this case, you'd probably want to flip those two. You'd want to say if the number mod 2 is equal to 0, then return true, otherwise return false, because then you can handle the negative choices. So asserts are great because they allow you to put a piece of code in to verify, yes, this is something I intended. I intended this to be what I'm telling you. All right, one quick little thing that we're going to throw in here, which really has nothing to do with error checking, but we need to teach it to you at some point. There is a concept called a virtual keyboard. You've seen it on your phone and on your tablets. Sometimes you would like to get it because you want the user to be able to enter something on the keyboard. So we have a method that is in your System 32 if you're using a Windows machine called OSK on screen keyboard.exe. And you can run that. So you can run a process in your code. So I can say I want to run osk.exe. By the way, you can also run Notepad and you can run a couple of other things. Anything with an exe, you can get it to run by clicking a button on your code, or if you have a GUI, or having it go through something telling you to get to execute an actual command. You can also use that for the calculator. Sometimes the calculator is useful if you want the user to enter numbers because the calculator returns back numbers. So just a quick thing on the virtual keyboard. There's more on this in the book, but it's just kind of neat to have that available. All right, that's the end of the lesson for Chapter 12, Exception Handling. Couple of things to remember. If you have an exception, the statements that are below the exception, still inside the try block, don't happen. Same thing with returning a value and having statements underneath it. Statements underneath it won't happen if you did a return. So if you had an exception and you went into your catch, the rest of the code in your try is not going to happen. Sometimes you may want to call the next line method in your catch block. So just be aware that adding an extra line inside of your catch block might make it clearer to the user so that your code isn't all bunched together. Variables declared in the try block go out of scope when you leave the try block. Now this is kind of a good programming convention, and you want to be careful. You can have multiple try catch blocks. You can have them in multiple places. You can also have one try catch block that catches everything. However, this is also why I want you to modularize your code. It's better to have the try catch block do as little as possible inside of the try catch. So don't have all of your code in one try catch block. Just catch when you think that something's going to cause an error. If you have a bunch of code in there, a bunch of statements that you know they're not going to cause you any trouble, don't put a try catch block around them. It's just a waste. You can also separate out methods and do a try catch block in each individual method, and that way you can handle your exceptions there rather than handling them in your main. Then you can do a try catch with your main because you know which exceptions will pop out. So be careful setting your try block, setting values. Place more specific catch blocks before the general ones. You saw the way that we had written it. There was an arithmetic exception, and then an index out of bounds, and then a general exception. If you put the general exception first, everything will hit that first. It's kind of like an if statement with a bunch of booleans. If the exception is arithmetic, go here. If the exception is out of bounds, go here. Otherwise, just go to the regular exception block. So be careful about putting specific catch blocks before general ones. You can write your throws clause for any method that doesn't handle it. So if I'm not going to handle my method, if I'm not going to put in a default value and move on with my life, and I need to throw an error, make sure you write a throws clause so that your main knows that that error is coming. And then handle your checked exceptions by either using a catch block or a throws clause. So if you want to check your exceptions, everything should either be in a catch block or it should throw that exception back to main and handle it back in main. Okay, let's talk about your homework. All right, your first one is exercise 1. I always think this one's pretty easy, but it's a good way to start with exceptions. Write a try block in which you prompt the user for an integer and then display the name that is at the requested position in the names array. I've given you an example here. Obviously, you're going to write this yourself. You are going to create an array of strings. And in that array, you're going to add, say, 10 people's names. I just have a couple in here. This came from the book. And then you're going to ask the user, please enter an index in the array. Obviously, 0 through 9. You're going to output the name at that integer or at that index, or you're going to catch the error if the index is beyond the range. So if they put in -1, if they put in 11, if they put in 52, you should handle an array index out of bounds exception nicely. You might want to throw this in a loop so that you can keep asking the user if they haven't entered one that works, so that I don't have to keep running your code over and over again. But this is going to be your first foray into using exceptions and try catches. Okay, let's go to the next one. All right, for exception 9, you are going to write an application that displays a series of 10 student ID numbers. You've stored them in an array. I've thrown a couple in here. You can write whichever ones you want. I don't care if they're in order. And then it asks the user to enter a test letter grade for the student. You are going to have a list of possible grades. So you have valid grades, A, B, C, D, F, and I for incomplete. You can choose to handle these in an enumeration. You can handle them when you're checking with maybe a switch if you wanted to do that. You want to make sure that whatever grade they entered is in the valid grade list, so that they did not enter a G or they did not enter an R. They have to pick one of the grades that you use. In your application, you are going to throw a grade exception, which means you have to go build a grade exception. You're going to build an exception, extending an exception class called grade exception. And you're going to handle that grade being the wrong one. If they enter the wrong grade, you are going to store an I for incomplete for any exception that is handled. So you know how to handle the grade. So if you end up in an exception with a grade exception, go ahead and put an I in for that value, and then make sure everything gets entered into some semblance of an array. Because at the end of the application, you're going to display all of the student IDs and all of their grades. So you need to figure out how you're going to handle their grades. You're going to have an array inside of an array. Are you going to do a class of students? However you want to handle it. You do not have to use an array. You can use an array list. You do not have to use the int array here with the ID numbers. You can do whatever you want. You just need to have 10 students. They have to have an integer for an ID number, and then they have to have their list of grades. Okay? Please ask for help if you have any trouble. If this is hard, if this is struggling, it's kind of supposed to be. You're learning stuff. That's great. But ask for help. Okay? We're going to have fun with exceptions today, and then we're going to move on to file I/O in the next chapter. Have a great week.